Okay, mole fraction and mole percent. So the mole fraction, and we've looked at fractions in terms of pressures when we were doing partial pressures. So mole fraction is moles of solute divided by moles of the whole solution. So again, it's the part divided by the whole. It's just that we're not multiplying it by any factor. So it's the amount of solute in moles divided by the total amount of the solute and the solvent in moles. So this becomes a little more difficult to calculate. And then if we want mole percent, we just take the mole fraction and multiply by 100. Okay, so this is a big problem. Here we've got 5 different things we're supposed to calculate. A solution is prepared by dissolving 50.4 grams of sucrose in 0.332 kilograms of water. The final volume of the solution is 355 milliliters. Calculate the concentration of the solution in each unit. So we're given the information we need to calculate all of these different concentrations. So we can do molarity, mole fraction, molality, mole percent, and percent by mass. Well, let's start at the top. Molarity. You have to know what these words mean in order to be able to calculate them. So molarity equals what? Moles over liters. Moles of solute divided by liters of solution. Well, we've got the final volume of the solution in milliliters. We need to convert that to liters, but that's not too bad. So converting that to liters is 0.355 liters. We need the moles of sucrose. We're given a mass and a chemical formula, so we can calculate this. 50.4 grams of sucrose. And then the molar mass, 12 times 12.01 plus 22 times 1.008 plus 11 times 16, 342.296. So 50.4 divided by that, 0.14724. 147, 3 sig figs, 2 extras to avoid rounding errors. That's the amount of sucrose in moles. Anybody else doing it can confirm that I did it correctly? No, you're all just watching. It's okay. So moles would be 0.14724 moles. So divided by the 0.355 liters, there's our 3 sig figs. So we would round that to 0.415 molar. Any questions? So mole fraction. What is mole fraction? It's moles of something over moles of something. Mole fraction is like a percent, it's just not multiplied by 100. It's the part over the whole, but in moles. So we need moles of sucrose over total number of moles. So we need moles of water plus moles of sucrose. Well, we got the moles of sucrose, right? We calculated that right here. So that's 0.14724. moles. And that's going to be divided by moles of water plus moles of sucrose. So we need moles of water. I'll just get rid of all of that. Well, we're given a mass of water in kilograms. So 0.332 kilograms of H2O. We need to convert that to grams. We can move the decimal point over, or we can write it out. Kilograms, grams, kilo means 10 to the third. Whoops, what did I do? Yeah, that was scary. 10 to the third. Kilograms cancel kilograms. And then we need to use the molar mass of water, 18.016 grams per mole. So 18.428 moles of water. Okay? So in the denominator here, we need to take the moles of water, 18.428, and add the moles of the sucrose, because we need the total number of moles. So we had 0.14724 divided by the quantity, 18.428, plus 0.14724, close parentheses, equal. Seems kind of low, but I guess that's reasonable. Anybody else get that? Okay. So rounding that, 0.00793. What's the unit on that? There's no unit. In the numerator, we have moles, and in the denominator, when we add moles and moles, we get moles. The units cancel out. A fraction doesn't have any units. What does molality mean? It's solute over solvent. Moles of solute, well, let's use, since we're, moles of sucrose per how much water? Kilogram. Do you know how much a liter of water weighs? It weighs a kilogram. The density of water is 1 gram per milliliter. If you multiply the top and the bottom by 1,000, you get 1 kilogram per 1 liter. So it's not like we're like doing something totally different here. This is very similar to volume of solution in liters. It's just a little bit different so that we can get rid of the temperature dependence. So the volume of the solvent in kilograms. Okay, so we've got moles of sucrose, 0.14724 moles. And we need the mass of the water. And that was given to us in kilograms. That was kind. 0.332 kilograms. 0.14724 divided by 0.332 equals 0.00035 That's wrong. What did I do? 0.14724 divided by 18. No. 0.332. Okay, that's better. I'm like, that can't be right. The molality and the molarity are often in the same ballpark. Okay, let's try that again. 0.44349. That's better. Is that what you guys got? And then the unit there, you can write moles per kilogram or molal. 0.443 italicized lowercase m. That's molal. Any questions? There's like a gazillion different sorts of problems that could be asked in this way. Being able to do units like this is a practical skill for everyday life, because if you're comparing ingredients in different consumer products, sometimes they're in different units to make it difficult to compare. If you're able to convert units, you could convert the one to the same unit as the other and compare them. There's lots of other different situations where you might want to do this in everyday life. Mole percent. Since we already calculated the mole fraction, this one's pretty easy, because mole percent is the mole fraction times 100. It's just taking that fraction and converting it to a percent. So 0.00793 times 100, 0.793%. What does percent by mass mean? It's a part over the whole in mass units. So the mass of the solute divided by the mass of the whole solution. So here we've got grams. Let's use grams. So grams of sucrose divided by grams of solution. So that's the sucrose plus the water. And it's percent by mass, so it's times 100. Well, we were given grams of sucrose, 50.4 grams. And then down here, grams of sucrose comes in there again. And then we have to add the mass of water in grams. Well, we did that up here, so that's going to be 332 grams of water. And don't forget the times 100. So we got 50.4 divided by the quantity, 50.4 plus 332. Close the parentheses, multiply by 100, 13.1799. Or 13.2. Any questions? Let's do a different one. What's the molarity of a 10.5% by mass glucose solution? So you've got this glucose solution. You know the concentration in percent by mass, but you need to know what the molarity is. Well, let's write down what we've got here. So 10.5% by mass. That means 10.5 per 100. It's mass, so it's 10.5 grams per 100 grams. Excuse me. Grams of glucose per 100 grams of solution. We're given the density, 1.03 grams per milliliter. That is the density of the solution. What do we need to find to get molarity? Molarity equals moles of glucose divided by liters of solution. There's more than one way to do this. You could start with the percent, because remember what I said before? Usually we take the units and we look at which one doesn't have per in it, and that's the one we start with, right? And we use the others as conversion factors. There's the train, the first train, 10:15. Wow, I know. Okay, moles per liter. The unit we're getting to has a per in it. So we could take this is a concentration unit, right? It's mass percent. It's got amount of glucose over amount of solution. We just need to change these units from grams to moles and from grams of solution to liters of solution. The other way you can approach a problem like this is say, well, I need to know how many moles of glucose and I need to know how many liters of solution. This involves kind of making something up because you're not given an amount. You're not told you have 1.5 liters or something. But you could say, well, what if I had 100 grams? And then you could calculate moles of glucose based on 100 grams of solution, and you could calculate liters of solution based on 100 grams. I'm going to do it the first way, though. So we can go from grams of glucose to moles of glucose. So we're going from grams of glucose to moles of glucose. That involves molar mass. And grams of solution to liters of solution, I'm given the density, so I can go from grams to milliliters and then to liters. This is like one of those problems from one of the early worksheets where we had like miles per hour converting to meters per second. So we've got 10.5 grams of glucose per 100 grams of solution. Actually, I'm going to do this. I'm going to use a different color there. I'll use green. 100 grams of solution. So we're converting two different things. We're converting grams of glucose to moles, and then separately, but in the same equation, we're converting grams of solution into liters. Let's do the top one first. So grams of glucose to moles of glucose, that's going to be the molar mass. So we're given the formula, 6 times 12.01 plus 12 times 1.008 plus 6 times 16, 180.156 grams per mole for the glucose. So that converts grams of glucose into moles of glucose. Anybody with me on that? To convert this number in the denominator, I want that unit to stay in the denominator, so I'm going to put all of my conversion factors, they're going to look upside down. But what I've got is the path in the denominator. Just like up here, this is all below the line. Grams to milliliters to liters. So I've got grams of solution to milliliters of solution to liters of solution. We're just looking at the bottom. To cancel grams of solution, I put the grams up here. So what's down there cancels up here. And then I need to get rid of milliliters, so that's going to go up there, milliliters of solution. And then I have to put numbers in. Well, milliliters to liters, that's a metric conversion. Milli means 10 to the minus 3. This grams per milliliter, that's the density that was given, 1.03 grams per milliliter. So now I'm going to do all of it. 10.5 divided by 100 divided by 180.156 times 1.03 divided by 1 EE negative 3 equals. That just seems awfully small. I'm going to check my math. Oh, that's what it is. There. I did the calculation twice, came up with the same answer, but both times it was wrong for different reasons. That usually doesn't happen. I was originally getting, I did come up with different answers, but they were both wrong. Anyway, I was coming up with 0.0006 because I didn't get the decimal point. Okay. 0.6. 0031. We got 3 sig figs going on there. This percent, 10.5 grams per 100 grams, that 100 is exact. So it's the 10.5, 3 sig figs there, 3 here. So 0, that's not a 0, 0.6, 00 moles per liter. That's the molarity of that sugar solution. Any questions?